This video is on the objective graph a cardioid from a polar equation. So this is the second video on this objective. I am hoping that you have seen the first one. And remember, a cardioid is just a special kind of a curve called a limaçon. And it has a special form, right? And the graph of a cardioid, right, is one of those, like, it looks like a heart shape, right? Cardio, heart. Yeah, so let's just take a look. So again, if you want to read more about it, right, click on more instruction at the bottom of the question, look at their videos, their notes, their examples, and hopefully those help you. So here I have r equals 4 times the cosine of theta minus 4, and I'm asked to graph this on a polar grid, right, a polar grid system. All right, so first of all, let's talk about those cardioids. Right, so a cardioid looks like this. R equals, some number plus or minus that same number, times the cosine of theta or times the sine of theta. It could be sine of theta as well. As long as these two numbers have the same magnitude, right? So this could be negative 4, positive 4, positive 4, negative 4, or they could both be the same sign. I mean, as long as they have the same magnitude, the same absolute value, right? Magnitude, absolute value, whatever. Then you have this cardioid shape, right? It'll look like a heart shape, right? Maybe opening up, or opening to the right like this or something, right? Well, it looks like a wider heart shape, but that's what these look like. Okay, so our example here, r equals 4 times the cosine of theta minus 4, or if you want to write it the way I had here, put the constant first, it'd be negative 4 plus 4 times the cosine of theta. So it's got this form, and both the constant term and the coefficient of cosine have the same magnitude, right? They're both the same absolute value, the same number. So this is going to be one of these cardioids. Right. All right, so let's go through this now. Again, if you've been watching my videos, I like to make another graph before I make the actual graph. All right, I make a graph in x and y to help me. I'll call it the xy version. Now this is not the rectangular coordinate equation. Right? I'm not converting this to rectangular coordinates. What I'm doing is replacing r with y and replacing theta with x. All right, so this is not, when you convert from rectangular to polar or polar to rectangular, r is not y, theta is not x. So that's not what I'm doing here. All right. So remember, y represents r values, x represents theta values, and then I'll graph this the way we're used to graphing our trigonometric functions, right? So again, x represents values of theta. So you can think of this as the x-axis or the theta axis. And y represents values of r. So you can think of the vertical axis as the y-axis or the r-axis. And then graph this like we usually would, right? The period would be 2 pi, no phase shift. And I break the period into quarters, right? Every pi over 2. And the midline would be at negative 4. Amplitude would be 4, so the highest value would be 0. The lowest value would be at negative 8. And yeah, cosine of 0 is 1. 4 minus 4 is 0. So I'd start off here at 0, 0. Then pi over 2 would give me negative 4. Pi would give me negative 8. 3 pi over 2 would back to negative 4. 2 pi back to 0. And I get this cosine wave. Right, like that. More wavy. Okay, and there's one cycle of the cosine wave. Now I went from 0 to 2 pi because I want to be able to go once around the polar grid, and going once around the polar grid will guarantee that I make my full graph. All right. So now I'm going to use this graph here as a guide, right, to make my polar graph. Right, make a polar grid. So I'm going to have vertical axis, and then the horizontal axis is the polar axis. And I'm noticing here the largest, r here, or the smallest, is negative 8. which means the largest distance any point's going to be away from the origin is 8 units. So here's 1, 2, 3, 4, 5, 6, 7, 8. And also I noticed some values of r are -4, so I'm going to make a circle here with a radius of 4 as well. Alright, so I'll make these 2 circles on my polar grid, and you can make more circles, as long as they're centered at the pole, centered at the origin. So here's a circle of radius 4, right, centered at the origin, and please forgive me, this isn't perfectly centered at the origin. Same thing here, let's make a circle of radius 8. That's pretty crappy. Sorry about that. Right, these distances, this should be 4 units apart. All right, these circles should be 4 units apart all the way around. They don't look like that. Okay, and then what I'm going to do is mark off these angle measures, right, these special angle measures that showed up on the x-axis up here. Now theta equals 0, right, corresponds to being on the positive side of the polar axis. Theta equals pi over 2 corresponds to being up here on the positive side of the vertical axis. Theta equals pi over here, theta equals 3 pi over 2 down here, and then back to 2 pi, right? Those were the angles that showed up. All right, so now I'm going to graph one piece at a time. So looking at this picture, all right, the first piece, from here to here, going from 0 to pi over 2, so that's between here and here. I'm in quadrant 1. But notice the values of y are negative. So when I graph, I'm not going to graph points in quadrant 1. I'm going to graph points in the opposing quadrant. I'm going to be graphing points in quadrant 3 because the values of r are negative. And I start at a value of r as 0. Right? And then I go to a value of r equals -4. So again, theta equals 0 is this line. Theta equals pi over 2 is this line. So I'm starting on this line and I want to end at this line on a circle with a radius of 4. Right, so I want to end with a radius of -4. I want to end on this circle with a radius of 4. Starting here, curling down. And I'll just make it like whoot, and then I'll just make it kind of curly. Right? Maybe I shouldn't have made it that curly, but just something like that. Right? Very rough sketch. Right? And then between pi over 2 and pi, right, between pi over 2 and pi is over here. But, if I'm between pi over 2 and pi, if I had positive values of r, I would graph in quadrant 2. But since all the values of r are negative, I'm going to graph in the opposing quadrant, in quadrant 4. And you see I go from a value of r equals -4 to r equals -8. So starting at this point, r equals 4, I'm on a circle of radius 4. I want to end over here at this, in this quadrant here, on this circle with a radius of 8. So again, this curve kind of continues and extends out, and I'm getting, it might be curvier than this, but like that, right? And then the other half is going to be finishing out this heart shape. So watch this, right? So from pi to 3 pi over 2. Well, pi to 3 pi over 2, that's in this quadrant, quadrant 3. But again, the values of r are negative, so I'm going to be graphing in quadrant 1, the opposing quadrant. And I'm going from a radius of -8 to a radius of -4. So on the circle with a radius of 8 to being on the circle with a radius of 4 up here, right, in quadrant 1. So maybe like this. This isn't great. Maybe like that. This is very, very rough. I'm gonna have the calculator Desmos do a better job than I'm doing. But start here, end there in quadrant 1. And then lastly, from 3 pi over 2 to 2 pi, that would be from here to here, 3 pi over 2 to 2 pi in quadrant 4. But again, I have negative values of r. So my graph's going to be over here in the opposing quadrant in quadrant 2. And I'm going from that point with a radius of -4 to a radius of 0. So I'm going around this circle with a radius of 4 to the point at the origin. Right? The value of r is slowly decreasing. And this should be symmetrical. It's not a very good graph. But do you see the heart shape? Right? You see the heart shape. I put it like that, And again, it should be symmetrical. This is actually kind of a crappy drawing, but I just want a rough sketch. Now, if I go to the calculator, I go to desmos.com, a free online graphing calculator, and let me put in that equation using r's and thetas that they gave me in polar. Right, r equals, it was 4 times the cosine of theta. You can just type out the word theta, and then minus 4, and you see there's a cardioid. All right. And just make sure, this point over here, remember, is 8 units away from the origin. These points that cross the vertical axis, see, are 4 units away from the origin on a circle of radius 4, just like in my hand-drawn picture, only it's a lot smoother and nicer looking. And let's see which one we choose then. All right, so not that, not that, not that. Looks like, nope, 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 nope. I don't think so, because this circle has a radius of 6. Oh, maybe, it might be this one. Because, remember, this point here needs to be 8 units away, and it's on a circle with a radius between 6 and 9, so that's probably 8 units away from the origin. These 2 points of the curve on the vertical axis need to be 4 points, and they look like they're on a circle with a radius bigger than 3. So I'm saying it's this curve here. Then you have another cardioid, but look, this point out here is, between 12 and 15 units away from the origin, not 8 units. So this is too big. And wonderful. All right, so again, hopefully watching me do this a couple times, looking at Desmos, and like I've been saying in other videos, you could just solve for r and put in r equals whatever in Desmos and look at that picture and compare it to whatever choices you need to make and get the right answer. You don't have to graph it by hand. I like to graph these by hand though, just to get a feel for how these polar curves work. So hopefully watching me do it by hand, looking at Desmos, reading the more instruction, looking at that when you need to, looking at the answer explanations, reading those, making sure you understand what those are saying, how they're doing things. And I'm hoping all this stuff helps you when you work on this material on your own. And thank you very much for watching.